So here's the question. Okay, we've the elevation plan and 3D graphic of a sail and sailboat are shown. The design on the sail includes a square inscribed in a circle, and the circle is tangential to two lines of the flag. To gain speed, the sail is rotated through 30 degrees about point O, as shown by the broken line in plan. Okay, so we have to draw the given elevation and plan. We have to draw that. Okay, and we have to draw the plan view in the black line there, and then it's rotated into this dashed line position. So part B, project an end elevation of the sail in the direction of arrow A. Okay, to show the rotated position. Now you don't have to include this here at the base. So I'm going to explain the concept in 3D to help you understand. Okay, so here's the sail, right? There's the elevation of the sail, there's the plan view of the sail appearing as a line here, just along here. Now, okay, so I'm going to show you, this is the original plan and elevation. So here the elevation is projected onto the vertical plane, just like here, the elevation, and then the original plan appears as a line, just like down here, that you can see there. Now, when we have to rotate it into a position at 30 degrees, the sail is rotated as shown. So it's not appearing now. There it is there. That's when it's rotated at 30 degrees. Okay, so you can see now, okay, that's the original sail, and then it's rotated. There isn't a second copy being produced. I'm just showing you in its copied position. Okay, now how does that work? Alright, well, on our drawing, what we do is we bring all the points down to the original sail, we rotate them, and then to draw the end view, we bring it across, up, and across from elevation. So look here in SolidWorks. So I'm just showing you how the corner here is got to there. So look, the point is brought from elevation to the unrotated sail, which is this one here, and then it's rotated onto the new sail, okay, which appears as a line in plan. So it appears as a line in plan, so that's it on the rotated position there. Here's the plan view of the rotated sign right there, okay, in the red line, and then we bring it over to our elevation, so straight across and height straight up over to our elevation. So this will be the position here, right there, and you can see now when this comes up. So there we have our end elevation there. So, and the heights remain the same. The heights haven't changed between the elevation and the end elevation. So on our drawing, okay, how we do the rotated end view is we bring all the points from elevation down to the line going across and plan the unrotated sign. We rotate them onto our 30-degree line. We bring them across, up, and across here. Now, if you have 2 points in one view, it can always be found in a third. So I'm setting up my elevation. I'm going to mark 110 on the base. The triangle has sides of 1, 110, 95 and 105. So I'm just going to draw up my axis there, and sorry, that was my XY line that I marked in, and I had marked 110 along it, and the line there, that's the axis of the flag, was 14 from the left. Now I'm going to set my compass now to a distance of 95, so I'll plot out the distance in 95, and I'll swing an arc from the left hand corner of the triangular sail before it's shaped in the with the curve as shown in the question. Then I'll set it to 105 and swing an arc, and they'll intersect to find the apex of the sail. Okay, then to get the curve, right, we've got 2 points on the circumference of the circle. The circle is radius 100, so I'm going to set my compass to a radius 100 and swing from both vertices of the triangle, and where they intersect are the is the center point of the arc. So I'm drawing my arc then. Then I want to get my circle, alright, and it's a tangent, the circle is a tangent to both of the lines on the left hand side of the triangle and the base. As you can see me pointing out with my mouse there, it's a tangent to those 2 lines my mouse is hovering over. So I'm going to bisect the angle here, so set my compass to any length, bisect the angle, okay, and I draw the bisector through, okay, and where it intersects the axis or the pole, that's the circle there. And then to get the point of contact between the circle and the edge of the triangle, I draw a 90-degree line, the normal through it, and then I can draw in my circle. So I'm going to draw in the square by drawing a 45-degree line through the center, and then the square can be drawn in. Now I'm going to set up the plan by bringing the points down. I'm going to draw my sail in its unrotated position shortly, so this is part A of the question. okay, in its unrotated position. So that's essentially part A done, and then as soon as I draw the 30-degree line, I'm starting on part B. That's the sail in its rotated position at 30 degrees through the center. So I have to swing the two end points of the sail in plan onto the 30-degree line, so I can shortly begin constructing my end elevation. So I'm going to drop point 2 down to the unrotated sail. So I went down a little bit too far there with my construction line. It's on the unrotated sail. You put your compass on the point there that you see in 40 mil from 1, and you rotate 2 onto it. Now I'm going to bring it over to end elevation. Alright, so my end elevation, because arrow A was looking from the left, I have to do it on the right. So I'm going to draw in my 45-degree line, bring my rotated points over to the 45-degree line, straight up, okay, and across from elevation. I can label in the points. There's the axis there at 0, and I can connect 1 to 2 and 1 to 3 and heavy down from O. Then I want to do the curve, so I'm going to divide it up into segments. I went up every 20. Okay, I'm going to bring the points across there to establish points on the curved surface, and I'll do an extra one up 10 from the top 20. Okay, so I'm going to follow the same concept. I'm going to drop those points onto plan after I label them, and they're going to go to the unrotated sail sign. So the horizontal line in plan. And then I'm going to rotate them onto the 30-degree line about point O in plan. And then as usual, I bring them across to the 45-degree line and up. And across from elevation. So bring them all across until they match their lines coming up from plan. So there's them in their rotated positions. In plan I marked them in. You follow them up, so you follow it across to the 45-degree line. Okay, straight up, and then you go across from point A in elevation. That's how I got A. There's B, so C, cross, up, and across from C in elevation, and D. I'm going to freehand sketch them in. So I'm just going to follow it with my pencil there. I won't draw it in here. I'll untape my sheet and do it myself. So there it is marked in. And then to do the curve or the circle, okay, I'm going to divide it into 60-30. So I'll number the points. So number the points. So I bring them down to the unrotated position and plan the line going across. Then I rotate them from point O, about point O, onto the 30-degree line and plan so the rotated sail. So I'm just plotting in my numbers there where the points are. Then to make life simple, I'm going to bring each point over one at a time. So over, up, across. So that's point, looks like 4. And then 9, I'm going to bring it over, up, and across. Now, 12. Now that point 12 there is wrong, but I will realise that there in a moment's time and fix it. So the position of 12 there I just threw in is incorrect, but I will realise it now very shortly that I marked it in the wrong position. I just brought over the wrong height. It's easy, mistake is easily made. So you can see there now I'm realising 12 was that's the correct position at 12. So I'm going to bring over my remaining points. So I'll freehand sketch those points in. So I'll take off my sheet to do that. There's just me freehand sketching some of them in. It's quite awkward with the visualizer over them. Keep your hand inside the curve when you're sketching them. It's more accurate. Then the last thing you have to do is, or I have to do the square. So I'm going to bring over the square to touch the curve on the ellipse in end elevation. And that's done. There we go.